Okay, so let's take a look at how we want to do a t-test and do a graph to see just how important or significant our data is. So what we're going to do is I've got this made up data here where let's say you are testing the effect of caffeine on plants. So you've got a treatment group, you've got a control group which has just water, and you track it every day how much a plant has grown. And in this case, we've got 4 members in each of those groups. We always want to run multiple trials. And in particular, that's going to be really important for us doing a t-test that we compare against those multiple trials. So we can't very easily do a t-test across the entirety of the data. So we're just going to look at how the plants grew overall. We're going to look at the last day of data, or pick a day. We're going to use day 10. So what I'm going to do is I'm just going to put the data across itself down here. So I'm going to copy this and say this is my data for my control group. This is my data for treatment group. And then we can analyze how well the plants did up to that day 10 point. So the easiest way to start looking for a relationship is to do a graph. So we can just select the data along with the headings that we want to look at, and we can go to Insert. We want a column graph is usually an easy way to compare 2 groups. And we'll just go with the default side-by-side style one here. And here we can see we've got a graph that looks like it has some fairly significant results. And we could copy and paste that into our Word document that we're using for our lab write-up. And we can say very clearly the control group was growing much faster. So in this case, caffeine, we would say, did make the plants grow faster. And that might seem counterintuitive, but if these were our data, that is what the data says. We go with the data in science. Now, I just made up these numbers, so who knows if it's true in the real world. Okay, so we've got our graph. If these numbers were a lot closer to each other, we wouldn't really be sure there was a connection here. And even with the graph, we don't know how clear that connection is. So I'm just going to make our graph a little bit smaller and out of the way here. And let's look at how we do a t-test, which is how we formally analyze how significant our data is. So what we want to do when we're going to do a t-test, let's just put our significance. It doesn't really matter where we put it. So we'll say, what is the significance of our data? And we're going to insert that right here. We're going to do, like I said, something called a t-test. The formula for it is t.test. Okay. But, oh, apparently we're still in that field. Go up here. I could actually just start hitting equal and typing in. There is another way you can enter a formula. You can go up here to Formulas, and you can go to Insert Function. And I've used t-test recently, so it's right here under Recently Used Functions. For most people, you have to go here, go to the pull down, go to Statistical, and you will find under the Statistical Analysis Tools, if you go way, way down, there's the t-test. And it describes it for us. It says here there's t-test array 1, array 2, tails, and type. And we'll get to what those mean in a minute. So we like that. We'll go t-test. Array 1 is our control group. Array 2 is our treatment group. For the tails, we want to say, in this case, let's just put in 1. We'll describe what those mean later. And we have different types here. We have a paired type, or 2-sample equal variance, or 2-sample unequal variance. The paired test would suggest that we were taking, say, 2 readings off the same person each trial. Well, obviously we didn't do that. We had 8 separate plants. Okay, and we don't know whether or not there's equal variance or not, so we'll just say we'll do type 3. And that's kind of our default. So it gives us a significance here. It says 0.0050, whatever. This means, let's actually look at this as a percent. We tend to understand percents better than we understand normal numbers. It's 1%, but that's actually rounding off. Let's give it a few more decimal places. Okay. We have just a 0.5% chance that this data is due to chance. So that means we're 95.5% sure that we have proven the control group grew faster. So if I want to change that significance, we want 100% minus that percentage, or we'll put 1 minus that up there. And now we can see we're 99.5% sure that the control group grew faster than the treatment group, and not just due to chance. And that's how we do a t-test. And we would call that our significance.